So we still on trigs, but now you have to learn the graphs. After we learn the graphs, then we can learn how to solve trig equation. So there are, well, 6 graphs you need to know, 6 in total that you're required to know for exams. I've never seen them, asked for you to sketch the graph or anything like that, but it is on your syllabus, so you have to learn it. So the first graph, okay, hold on, before we start that, we know the 3 basic trig functions: sine, cosine, tan, right? So this is what your syllabus requires you to know. The functions sine kx, cos kx, tan kx, where k is 1 or 2 for the range x is greater than or equal to 0, but less than or equal to 2 pi. That's 2 pi radians, right? Remember, 2 pi radians is the same as 360 degrees. All right, so let's start. Sine. How exactly? So that's what the sine graph looks like, right? Sine x. So in this case, k is 1. So sine of x, this is cos of x. K is 1 in both cases, right? Okay, yeah, you need to know how to sketch this graph. Notice this. So for my physics people, this is called the crest of the wave. This top part right here, right? Anybody doing physics would know this. This is called the crest. And notice that the peak for the sine graph is at 90. 90 is also known as pi on 2 radians, right? The trough, which is this bottom part here, is at 270 degrees, also known as 3 pi on 2 radians. So yeah, you could just learn this off, but I need to make sure you understand how they came up with this graph in the first place, right? So there's something called simple harmonic motion, right? You wouldn't know about this yet, but anybody who decides to do physics, anyone who decides to do physics, you would learn about this later on, right? So simple harmonic motion. Anybody who does physics, do you know about the pendulum?
Yes, miss.
Yeah.
Gosh, you don't sound too sure then.
And the Pythagoras theorem.
Oh no, hold on, wait. Well, yeah, but a pendulum is this thing with like the string and then it has a mass at the end and it swings like it oscillates. Sorry, I can't help it. Right. So it oscillates at an amplitude. The physics people should know that. Do you know about that?
Sí, professor.
C.
All right. Well, if you decide to do physics for A levels, you learn about simple harmonic motion. It's similar to the pendulum where something would swing back and forth, right? And I won't go into the details because I know some people may not be interested in this. You don't want anything to do with physics, so I'll make this as quick as possible. So what they found out is that a body, so we'll call this a body, right? That's what we do in physics. A body that's oscillating will create a pattern that looks like this. This, as we know, my physics people, this is called a wave. They named this wave the sine. So there's this, and there's a line going through here, right? This will represent time, and this is distance. So they found this pattern, right? Hold on, this is not right. So like I said, you don't need to know this. This is just, especially for the people who are interested in physics, you will learn about this eventually, right? So it created this pattern. They call this the sine. Oh my, hold on. Right. They call, yes, it looks like a triangle shape. Right. They call this the sine graph. Why sine? Because the word sine, S-I-N-E, in Greek means curve. They saw these curves, so they called it a sine graph, right? So if I these mathematicians, say I have my Cartesian plane, right? Okay, hold on, let me just clear this up. So that simple harmonic motion thing, that's where they first discovered the whole wave pattern. Say I have my Cartesian plane, x, y axis. If I take the sine function, the sine function, in the calculator. So sine of x, right? That's my function. For any value of x, when they just put random values of x into this function, sine of x, they realized that the pattern was just like that. So it started here, it went all the way up, it came down here, went like this, came here, down, side, up, down. And then when they connected these lines, they realized that it formed a wave, just like we saw just now. Well, yeah, this is a wave, right? And they realized that you see this value here. Hold on. Right, anyways, you see this value here. Why is this like this? Anyways, that value there, not that, this value here. This was 90. They found out that this was 180. They found out that this was 270. And this was 360. So if you punch into a calculator, so this is 0, right? If you punch into a calculator sine of 0, you'll get 0. If you punch in sine of 90, can anybody tell me what value you get when you put sine of 90?
Oh yes.
1.
Remember that? I used to.
Sine of 180 is 0, right? Hence it's on the x-axis. The y value is 0, right? If I put sine of 270, can anybody tell me what answer that is?
-1.
-1.
-1.
Sine of 360 is 0, hence it lies on the x-axis. Same thing here. Sine, this would be -90. Sine of -90 is also 0. Sine of -180, let me 0 now. Sine of -90 is -1. Sine of -180 is 0. Sine of -270 is 1. And sine of -360 is 0, right? So by plotting all these points, they realize that this is the pattern that was created, right? And that's how the sine graph came about. Notice for the sine graph, the maximum value that y could be is 1, and the minimum is -1. So for any value of x you plug into this function here, so say I wanted to put sine of 1,000. Can anybody tell me what's the value? What's sine of 1,000?
Negative 0.9848077753.
Okay, which is greater than -1. Put sine of, I don't know, sine of 29,000. Tell me your answer here.
0.342020143.
Which is less than 1. What sign of a million?
How many zeros a million have again, miss?
6.
6. I think I'll put 5. 1, 2, 3. Yeah, I'll put 5. 1 sec. Oh, 0.
Negative
Negative, yeah.
0.9848077753.
All right. So the point of me telling you to do that is for any value of x in this function, sine of x, any value of x, right? A million, a billion, 2 billion, negative 23,000. It does not matter what value of x this is. The value would never cross 1 or minus 1. The maximum value is 1. The highest this could go is 1. And the lowest is minus 1. It will never go out of that boundary, right? You would never be able to put a value for x in this function here and get a number that's greater than 1 or less than minus 1. That is why we say for our sine graph, the maximum value is 1 and the minimum is minus 1. You good with that?
Yes, miss.
Yes, miss.
All right. But say I have sine of 2x. Just now I had sine of x, now I have sine of 2x. What would that graph look like?
Sine of 2x.
That was a rhetorical question. If you want to answer, go ahead. I'm not stopping you.
Syntax error.
No, you can actually put sine of 2x in your calculator. So we just said this is what my sine graph looks like, right? It would go up.
Miss, is there any which way like we can learn it like easier or like faster? Any easy way to learn it?
To learn the graph. To learn the graph.
Yeah, to learn like the sine x and so yeah. Like no, like to know the like the stuff with the pi, like pi something, you know. On the first page we had seen.
You mean the special angles? Is that what you're talking about?
Yes.
Yes, there is. I'll show you that next class too. Remind me. There is an easier way to do it, you know.
Okay, miss.
So this is my graph of sine x. But what does sine 2x look like? Well, for my people who will decide to do physics for A levels or some type of math, like pure math, integrated math, applied math, you learn something. You'll have to learn how to sketch exponential graphs, right? So just graphs of function. And there's something called a horizontal compression. So f of x. This function, sine of 2x, is in the form f of ax, where a is 2, right? Like I said, you don't need to learn, you don't need to know what horizontal compression is. That's just me telling you to help with your understanding. So by having this 2 in front of my x, what that would do is kind of, how to explain this? Like squash my graph. So what do I mean by that? You see this 180? This is 90, this is 270. Sine of 2x, it would also pass through here. okay, let me use a different color. Sine of 2x would also go up here. So remember, this is 1, this is -1, right? That's the maximum and minimum values for the sine graph. So it will still go up to 1. But you see, instead of intersecting at 180, sine 2x is going to intersect at 90. Come down to -1, go up to 180. Go back up to 1, come down at 270. Go down to -1, go back up to 360. So the red, if you want me to draw it over, like instead of having it as 1 right there, like on the same plane, just let me know, right? I could.
No, it's better. It's better like that so we can understand.
Yeah, miss, you can see a side-by-side comparison.
Yeah, you know what I mean?
Mm-hmm. So sine of x looks like the yellow. Sine 2x, I told you, it's called a horizontal compression. When you think about compress, you think about, squashing something down, right? So that's why this graph right here, the red versus the yellow, the red looks like it's squashed in, right? For my physics people, you know about wavelengths. Well, I would hope you know about wavelengths. This, the yellow, this crest to this trough, well, this right here to this right here, that's one wavelength, right? But so the yellow only makes one wavelength, but the red makes two wavelengths, right? But I didn't want to talk about that for my non-physics people. Just for the physics people, the yellow makes one wavelength, so one cycle, but then the red makes two cycles, right? Why? Because of the 2 in front of it. So 2x means 2 cycles, 2 wavelengths. That's for my physics people, right? For my non-physics people, don't worry about that. You just learn about squishing the graph. Physics on top. Yep. Yeah, man. Right. So yes, you just need to learn this. I did this to help with your understanding, but it is crucial that you know, like you have to learn this, okay? Just a reminder, 90 in radians is pi on 2, 180 is pi, this is 3 pi on 2, and this is 2 pi. Right, so just in case they ask you for radians, this right here is in degrees. This would be pi and everything, that's radians. So can I erase this now?
Yes, miss, I got it.
Oh,
Wait,
yes.
let me take a picture real quick. Let me take a
I
quick
sent you the picture.
Oh, my bad.
Imagine not drawing it out.
Sorry, no need to shout, Josh. Chill.
All right, my boy, dedicated.
Okay. You have a bad physics teacher. That is unfortunate. Okay. Cosine. So my cos graph, what does it look like? Well, it looks like this. Unlike the sine graph that starts at 0, so it goes up, comes down, goes up. My cosine graph starts at 1, then it comes down and goes back up to 1, right? So that's the difference between my cosine and sine graph. So let me just draw the cosine graph. So cos of x, this is what cos of x looks like. Y, x, this is 90, this is 80, 70. This is in degrees, right? 36. Then I have a minus 90, minus 180, minus 270, and my minus 360. Just like the sine graph, the maximum value is 1, the minimum is -1, right? And if you just want to double check that, punch into a calculator cosine of any number at all. It does not matter how big or how small. You will never exceed 1 or -1. Okay, it will always stay in that range. The highest possible value is 1.
Miss,
No, it is -1. Yes.
excuse me.
Yeah.
The yellow stuff, the red one. When we were doing the one with two of them, the cos x was sine x to x. Was sine to x or no? That was a whole different thing.
No, what we're doing before that sine, this is
Oh,
cosine.
that's only sine. Oh, okay.
Yeah.
Oh,
Yeah.
okay, okay.
What we're doing, we drew sine x and sine 2x. Now we're doing cos x and cos 2x. All right?
Okay,
Miss, I have a
okay.
question.
Yeah, no problem. All right.
Yeah.
So if we could do the function sine on cosine on a graph, couldn't we do like sine inverse and cosine inverse?
Yeah.
Okay, lovely, miss. We're doing that today?
You're not required to know it for your exam. It's not
Oh,
only for us. But if you want to know, sure.
No, 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 no. We only need to know stuff for CXC. Like, chill, Josh, chill.
Okay. Oh gosh, that was funny. All right. So this is 1, this is -1. Just like the sine graph. However, in this case, instead of starting from 0, going up, coming down, whatever, we're starting from 1, going down to 90, to -1, then up to 180, oops, down. Oh, hold on, no. Drawing the wrong graph. Right.
miss, I'm sorry for the dude that's drawing the graphs along with you.
What? I didn't hear anything just now. That's what this looks like, right? It doesn't pass through 180. It goes from 90 to 270. Somebody was saying something, but you broke up, so I don't know. But yes.
Oh, miss, no problem. Never mind.
Alright. It goes down to 9, well, -90, all the way down to -1, right? Then back up to -270, actually 6. So this is what cos x looks like. Like I said, how did they get this graph? Well, they put random values of x, so for all the values of x, they realized that it made this pattern, right? When they put cosine of 0, they got 1. That's why there's this point. So let me put. So say I put into my calculator cosine of 0, I get 1. So a point was plotted here. If I put cosine of 90, I get 0. If I put cosine of, well, this is supposed to be 180, right? So this is the 180. Cosine of 180, I get -1. So by plotting all those points, when they join them, they realize that it made this kind of pattern. This pattern is known as a wave. All right? Everybody good with that?
Yes, miss.
Yes, miss.
All right. I need to show you one thing about the cosine and sine graphs. All right. Sine. This is literally the most basic trig function, right? It's like the OG. Yeah, right? It's the OG. Cosine. Cosine of x. Okay, so you know about cos of x. I hope you know that cos stands for cosine. But what exactly does cosine mean? Does anybody know?
Not here, miss.
Okay.
It's cosine.
Do you know what cosine means? Like what it stands for?
Cooperative sign.
I was just about to say that.
Now,
What?
if you change it to
Can you repeat that?
Cooperative sign, cooperation sign, or something like that.
No.
Complementive sign.
COVID sign.
Complemental sign.
cooperative sign.
Complemental sign.
So we did
What?
we just smart like that.
Right. So cosine means complement of sine. So when I say complement, do you know what I mean? What does complement of sine mean?
Opposite.
Everything outside
Opposite.
of.
No.
So complement doesn't mean opposite.
It gives sign something. It gives sign like, you know, like it. I don't know how to say.
But
If I ask you, what are complementary angles? What would you tell me?
angles that add up to it, thing
The thing.
to
What is thing?
180,
No.
180.
No.
360,
No.
270,
No.
90.
Yes.
Oh, there we go. 5th time's the charm.
Yeah. So supplementary angles add to 180. Complementary angles add to 90. So if I have this and I told you that this angle here is 30, what would be this angle? If this whole thing is 90 and this angle right here is 30, what would be this angle?
No, 60 degrees.
Yep. These angles, 60 and 30, would be known as complementary angles. Why? Because 60 plus 30 degrees is going to give me 90 degrees, right? Complement of sine, we said that's the definition of cosine. So what does that mean? Let me erase.
Oh, miss, I think I know what you mean, miss. Like when you have sine of a specific number, the cosine of the other number, if you add those two together, it give you 1 or something like that.
Not 1.
-1, 0.
No.
Other guesses.
All right. Hold on. Okay. So, right, let me show you. So we said that that cosine is the complement of sine. When I say complement, I'm referring to complementary angles. Complementary angles means that the sum of the angles is 180. And that is why we say that the relationship between sine and cosine is, say I have sine of x, that's my function. Sine of x is the same as saying cosine of 90. So assuming that this is in degrees, right? Sine of x is the same as saying cosine of 90 degrees minus x. Okay, so let's prove that using like a random value. Somebody give me a value for x.
19.
19. Okay. Anybody tell me what's the sine of 19?
0.325568154.
Okay, we are not putting that entire thing. We just put that. 0.3.
0.33. You can say.
33. Hold on.
No significant.
0. Oh, yes. Hold on, wait. Okay, we have a little while. 2 minutes. All right. So I'll just leave it at 0.325. Well, that wouldn't be correct because it'll be 2.6. Okay, we're leaving it as this. According to this, I'm supposed to get the same answer if I said cosine of 90 minus 18. I mean 19. Well, so that's that. Cosine of 71. What's cosine of 71? Anybody?
Miss the same thing, like 0.33.
Good night. Good night.
Good night. Well, it's not nighttime yet. So good evening. Hi. Right. So yes, this is true.
Yeah, Miss, we got the same thing.
What?
Miss, I got this like 0.33.
Right, yeah. So just like this says, cosine and sine. Cosine is the complement of sine. So whatever angle this is, the cosine of 90, assuming that the angle is in degrees, the cosine of, oh, somebody's mic, hold on. The cosine of 90 degrees minus whatever this is, I'm supposed to get the same answer. That's why sine of 19 gives me 0.33. And sine of 90 minus 19, which is cosine of 71, gives me 0.33 as well. So that's the relationship between sine and cosine. Similarly, if I said I wasn't supposed to do that. But anyways, similarly, if I said sine of, okay, so let me say this is cos of theta. Cos of theta is the same as saying sine of 90 degrees minus theta. Okay, so just rejoin after this. Yeah, it's going to end on a soon. So just rejoin. Let me end it.
Miss, before we that timer goes off, do you believe in COVID-19?
Yes.
Okay, Miss, just checking.
LOL.
All right, let me end it.